Welcome to this session titled ArcGIS Indoors, Developing Indoor Mapping Apps. My name is Jason Hine, and I'm one of the product engineers on the ArcGIS Indoors team at Esri. This session is for any IT or GIS professional that needs to provide indoor mapping app functionality to an organization. Yes, we'll be looking at the code in some of the demos, but as you'll see, you don't necessarily need to be a developer to make great indoor mapping apps. There are three ways you can go about making great indoor mapping apps. The first is to configure an out-of-the-box app. You just plug in a prepared indoor map and any routing or other services you may need, configure app settings for function and style, and that's it. You can also integrate third-party apps, such as work order systems, to create seamless experiences for your users. And if you need to, you can develop a custom indoor mapping solution using the APIs, SDKs, widgets, and other resources we'll be exploring in this session. Just remember, we don't need to reinvent the wheel. If an out-of-the-box app can do it, why not use it? So, to get going, we need to understand a little bit about the ArcGIS Indoors product to give us some background and context for the app development discussions and demos coming a little later in the session. Let's start with a brief overview of what ArcGIS Indoors is. ArcGIS Indoors is an indoor GIS for asset, space, and building management. It provides data management tools to aggregate CAD and BIM floor plans into a geodatabase to build indoor maps. It includes an out-of-the-box app for space management that supports office assignments, space allocation, and office hoteling. It provides a web and mobile building occupant experience for workspace reservation, location sharing, facility incident reporting, and wayfinding. And it supports facility operations through problem reporting, asset management, and mapping for safety and security. In addition, it offers device tracking to support finding and tracking people indoors. When purchased, Indoors includes ArcGIS Enterprise, ArcGIS Pro, Survey 123, and other components needed to power the Indoors system. ArcGIS Indoors is a complete system for indoor mapping that can be deployed on-premise as an ArcGIS Enterprise deployment or hosted in the cloud as a software-as-a-service offering through ArcGIS Online. Irrespective of the deployment model, at the heart of ArcGIS Indoors is an extensible information model. This information model is capable of modeling building floor plans, a campus-wide indoor routable network, and space assignments. These items are modeled as simple feature layers that can be published as map and feature services. To support indoor data management, ArcGIS Indoors offers an extension to ArcGIS Pro that supports creating the Indoors information model, loading CAD and BIM floor plans into that information model, authoring indoor maps, and more. Note that it's typically the GIS professional's job to load floor plan data into the information model and prepare indoor maps. In this session, our focus will be on consuming those prepared indoor maps in our apps. In the summer of 2020, Esri released ArcGIS Indoors Space Planner, a web application for space management that supports managing staff office assignments, office hoteling and hot desking space designations, and more. ArcGIS Indoors also offers Indoors Viewer, which is a web application that supports building occupants with campus-wide floor plan visualization and navigation, wayfinding, location sharing, and incident reporting. The viewer also supports a visitor kiosk mode that can run on a touchscreen monitor or a device at a reception area to support site visitors. ArcGIS Indoors also includes an iOS and Android native mobile occupant experience that it supports many of the same capabilities, but also supports workspace reservations, office hoteling, and supports interfacing with an indoor positioning system to provide a blue dot experience indoors, showing users where they are on a map. Esri also offers their own indoor positioning system that can be used with ArcGIS Indoors. And you can integrate data from work order, asset, and incident management systems to build a common operating picture that can support business operations and analytics within your organization. Let's take a little closer look at the out-of-the-box web and native mobile apps included with ArcGIS Indoors. The Space Planner web application template supports your organization in identifying space vacancies, performing staffing and office assignments, co-locating teams, performing what-if scenario planning, and it has the ability to export assignments for import into external employee systems. This application will support organizations in consolidating unused space, increasing the use of limited space, and defining space allocations. The Indoors Viewer is a web application template for occupant and visitor users that supports indoor wayfinding, office hoteling, location sharing, and incident reporting. This application can run on a touchscreen kiosk for visitors or in a computer browser for occupant users, or even a mobile phone browser for either kind of user. This application is fully brandable to the organization's color scheme, supports 2D and 3D maps, and can integrate with work order and asset management systems. The native mobile occupant experience offered by ArcGIS Indoors supports many of the same capabilities of the Indoors Viewer in addition to supporting the ability to interface with indoor positioning systems to give the user a blue dot location of where they are on a map. It also supports real-time location sharing, conference room booking, office hoteling, and integration with the device's calendar to help users find indoor appointments. Again, all these out-of-the-box apps are configurable with no coding required. Before developing a custom indoor mapping app, you owe it to yourself to try these out. Next, we're going to look at the extensible information model that's behind every ArcGIS Indoors map. We need an understanding of this model because we'll be using it when programming our indoor mapping apps. The ArcGIS Indoors information model organizes indoor spatial data into a number of different feature classes. For our purposes today, we'll focus on these 5: sites, facilities, levels, units, and details. A large organization that has properties dispersed across a region or around the world can represent those properties as polygon features in the Sites feature class. For example, shown here is one of Esri's many sites, our main campus in Redlands, California. A polygon in the Facilities feature class can represent a building or other structure, such as a parking garage, that's located on a site. Polygons in the Levels feature class can represent the different floors found within each facility, including the ground floor, basement levels, mezzanines, and even service levels. Unit polygons can represent rooms, hallways, stairwells, and other spaces found on a level, while a level's architectural details, such as walls, doors, and windows, are represented as polyline features in the Details feature class. The features in these simple feature classes relate to each other through unique ID attributes and spatial relationships. As indicated on this diagram, each site polygon in the Sites feature class may have one or more facilities associated with it, and conversely, each facility polygon is associated with one and only one site. Likewise, each polygon in the Facilities feature class may have one or more associated levels, while each level is associated with one and only one facility. The same kind of relationship exists between levels and units, and also between levels and details. It's worth noting that there is no such association between units and details features. They are both associated with levels, but not directly with each other. This table lists attributes present in each of the feature classes. The ID fields function as primary keys for the hierarchical relationships between these feature classes. For example, if we're looking at a units feature representing a conference room, the value of that feature's level ID field will relate to one of the features in the Levels feature class. And that level feature's facility ID will in turn relate to one of the features in the Facilities feature class. As developers, we can use these ID fields when we need to query related features in the Indoors data. The Levels feature class has two numeric fields, a vertical order field and a level number field. The values in the vertical order field are guaranteed to be ordinal, so that the ground floor of a facility will always have a vertical order value of 0, with consecutive positive integers for levels above the ground floor and consecutive negative integers for levels below. On the other hand, values in the level number field can be unique to each facility and may not be consecutive. In fact, some taller buildings may not have certain floor numbers that some people consider unlucky. Consider this elevator in Shanghai that's missing floor numbers 4, 13, and 14. So, when our code needs to do some calculation involving level numbers, such as determining how many elevator stops there are between two levels, we'll want to make sure to use the vertical order field. The Sites, Facilities, Levels, and Units feature classes have attributes for storing name strings that might be suitable for use as labels or in pop-ups. The Units and Details feature classes have use type attributes to store strings describing the use or function of each feature. Units might have use type values like office, corridor, kitchen, or restroom, while details might have use type values like door, interior wall, or window. We might use these use type field values to label features, as information in pop-ups, or when setting feature symbology. And lastly, there are height and area attributes that we can use when we need to do calculations involving those measurements, such as determining the total floor space of a facility. Most indoor maps are going to include other layers with features that represent people, places, or things that our users may want to locate inside a facility, such as water fountains or fire extinguishers. We need a way to relate these kinds of features to the indoor information model so that we can include them when visualizing indoor data or performing indoor routing or other analysis. We use the term floor-aware to describe a map that uses the Indoors information model to relate sites, facilities, levels, units, details, and other indoor features included in the map. To see how this works, let's watch a brief demonstration of how the floor-aware map support coming soon to ArcGIS Pro enables a convenient new floor navigation tool called the Floor Filter. Here is a map where we have already used the indoor geoprocessing tools to import our floor plans from CAD files into these simple feature classes. Note that we can currently see units, details, and other features for multiple floors at once, making it more difficult to see which features belong to which floors. The Indoors information model allows us to configure this map to be floor-aware and activate a new filter to make the indoor data more legible. To make the map floor-aware, we start by configuring the map to identify the layers that represent our sites, facilities, and levels. Remember that these layers each have ID attribute fields that relate each facility to its site and each level to its facility. Next, we configure our units, details, and other map layers to identify the attribute with the level ID values that relate each feature to the floor it's on. The map is now floor-aware, as indicated by the appearance of the floor filter in the corner of the map. Filtering by site allows large organizations with dispersed properties to quickly navigate the data. We can further filter the data by selecting a facility, and the map pans and zooms to show us the default floor of the facility we've selected. Now that we've selected a facility, we can select whichever level within that facility we want to visualize. This filters the features in the units, details, occupants, and other layers we've configured as floor aware to just show those for the level we've selected. The floor filter is filtering the data in our floor aware layers, making it much easier to visualize those features. Beyond ArcGIS Pro, support for floor aware maps is also coming to Esri's Runtime and JavaScript APIs, so that you'll be able to take advantage of floor awareness when developing your own indoor mapping apps. Let's take a sneak peek and see how we'll be able to implement floor filtering when developing with the ArcGIS API for JavaScript. We have already taken the floor aware map we configured earlier and published it as a web map with hosted feature layers. With support for floor awareness coming to the ArcGIS API for JavaScript, we can construct the new floor filter widget, associate it with the map view displaying our floor aware web map, and then add the widget to the app's user interface. The widget handles the rest of the configuration automatically, using the floor aware configuration information stored in the web map and its layers. If we were to examine the web map's JSON, we would find that the web map has a map floor info object with properties defining which layers in the map contain the sites, facilities, and level features from the Indoors information model, and the hosted feature layers each have a layer floor info object that indicates which field in that layer contains the level ID values. The floor filter widget is automatically configured to locate and use this data. We just need to add the floor filter to our view and we're done. Let's take a look at the JavaScript API's new floor filter widget in a simple indoor mapping app. With the floor filter widget added to our map, we can use it to focus the map on a particular site. We can then either search or scroll to find and select a facility, and the widget pans and zooms the map to show the facility's default level. We can then hide the list of facilities and select the level that we want to visualize. And in case you're wondering, yes, this widget also works with 3D scenes. The floor filter is composed and styled using Calcite Web, the same responsive framework used by other widgets in Esri's JavaScript API. As an alternative to the new floor filter widget, you can still use the older open source floor filter widget that we made available on GitHub back in 2019. Aside from the floor filter, we can also use our knowledge of the Indoors information model to develop our own indoor map functionality. Let's look at a quick example of how to query indoor data. Let's suppose we want a function to query our indoor data to find conference rooms on the ground floor of Building M. Which layer from the Indoors information model is going to have features representing conference rooms? That's right, the Units layer has features representing rooms, hallways, and other spaces on a level. So the first thing we need to do is get a reference to the Units layer. We can do this by filtering all the layers in the web map to get just the ones named Units. If we can't find the Units layer for some reason, we should bail out of our function. Next, we need to get the layer view for the Units layer so we can access the unit features within the layer. Once we have access to the features, we can create a query parameter object from the Units feature layer and specify a where clause. You will recall that units have a use type attribute. In our indoor data, conference rooms have a use type of conference room. And we also want just conference rooms on the ground floor of Building M. Recall that units also have a level ID attribute. In this case, I know the level ID value for the ground floor of Building M is 1000.us01.main.m1, and for the sake of time, I'm going to hardcode these values in, but if we wanted to, we could get these values dynamically using additional queries. All that's left is to execute the query and zoom to the results. Let's also use the feature layer view's highlight method to make it easier to see the conference rooms on the map. Our function is already wired to a button, so let's try this out. Clicking the button calls our query units function, and the result is all the conference rooms on the ground floor of Building M, nicely highlighted. Earlier in the session, we took a brief look at the Indoors Viewer application and mentioned that it supports integration with third-party apps. Integrating the Indoors Viewer with work order, asset management, incident reporting, or other systems is a quick and easy way to create powerful indoor applications, so let's take a few minutes now to see how it's done. As you may recall, the Indoors Viewer is a configurable, brandable web application template that supports a number of functions, including indoor wayfinding and location sharing. These functions fit naturally into many visitor, occupant, and employee scenarios. For example, when a visitor arrives on campus and needs to find out where their next meeting is, they can use a touchscreen kiosk running Indoors Viewer to search for the meeting event and get directions. As another example, an employee who has found a malfunctioning wallboard monitor can use the Indoors Viewer on a mobile device to determine its exact location within the building, so they can report it to their organization's service department. But we can do one better. We can apply Indoors Viewer integration patterns to these and other scenarios to provide users a more seamless experience. In our first scenario, we can configure the Indoors Viewer to provide the visitor a QR code that they scan with their mobile device. Scanning the code launches their device's web browser and opens the Indoors Viewer complete with the route they found using the kiosk, so they'll have turn-by-turn directions in the palm of their hand as they cross the campus to their meeting. For the second scenario, we can configure the Indoors Viewer to integrate with the service department's work order management system, so that clicking a button in the Indoors Viewer opens a form to submit a new service request with the location information already filled in. The Indoors Viewer supports integration in multiple ways. It supports custom launch actions, allowing the user to launch other apps directly from the Indoors Viewer with the ability to pass location and other information to the app being launched. It also supports smart launching of the Indoors Viewer itself, using parameters in the app's URL to define a location or a route to be shown immediately to the user. Let's see how we can configure custom launch actions in the Indoors Viewer. We're going to give employees an easy way to report an issue by integrating the Indoors Viewer with Survey123. We're going to see two places where we can configure launch actions. The first is when authoring an Indoors map in Pro, and the second is when configuring the Indoors Viewer. One advantage of setting up launch actions here in Pro is that they'll persist. We can publish and republish web maps and make multiple Indoors Viewer apps without needing to configure separate launch actions for each one. From the View tab, the Windows section has an Indoors drop-down with an option to configure Indoors launch actions. We just need to click the plus button to create a new launch action. The first thing we need is to provide a description indicating what the action does and who it's for. This description is just for our information. Users won't see this description. The label is what the user is going to see on the launch action button when they're using the app. We'll keep this short so it displays well when the app is running in a mobile device browser. Next, we need to provide and enable at least one link to the application being launched. ArcGIS Indoors supports web URLs, as well as native app URIs on mobile devices. If our Indoors Viewer app will be used on both desktop and mobile devices, we can provide and enable both types of links, so the Indoors Viewer can launch native mobile apps when on a mobile device, and launch web apps when on a desktop device. The Units features have attribute data that we can pass along as part of the launch action. In this scenario, we're going to pass along the unit ID and use type field values. To do this, we append URL arguments to specify the layer and attribute field containing the data we want passed. We also need to know the names of the fields in the form that's going to receive the data. In Survey 123, the field names can be viewed and edited when first publishing a survey by clicking on Modify Schema. We build the URL starting with the path to the survey itself, then appending the arguments. I'll do this on a separate line here so it's easier to see. We need a question mark, then the keyword field, a colon, and the name of the survey field as seen in the survey schema, so room. Then an equals sign, and inside curly braces we'll put the layer name and attribute field name, so units.unitID. We'll use an ampersand to append our second argument. Field colon useType equals curly braces units.useType. Let's pull these two pieces together and copy and paste the whole thing in as our web link. Next, we specify the Indoors categories and map layers to which we want to apply the launch action. We'll select just the Units layer so that the launch action will be made available when the user clicks on a room, but not when they click on other kinds of features on the map. We've finished configuring the launch action. Once the map is republished, we should see the launch action when configuring the Indoors viewer. This is the second place we can configure the launch actions, and any changes we make at this point will only affect this Indoors viewer application. Let's test out our launch action here in the live preview. We click on a unit to open its info card, and under the More item, we can see our launch action. If we click it, the Survey 123 form opens, and the first two fields are automatically populated with the values from the unit feature. Now that we've seen how to configure launch actions to enable a seamless experience passing users from Indoors Viewer into other apps, let's look at how to do the same when the user is coming from another app over to the Indoors Viewer. Generating a Smart Launch URL for a specific location is easy to do from the viewer itself. We just need to find and select the meeting space to open its info panel, and when we click Share, we can click Send Email to have our default email client open a new email with a Smart Launch hyperlink already created, or we can click Copy to Clipboard and paste the Smart Launch URL wherever we need it. As a third option, we can click down here at the bottom of the info panel to get the Smart Launch URL as a QR code. We can also create a Smart Launch URL for a route with start and end points. To do this, we use the viewer to generate a Smart Launch URL for the start of the route and copy that into a text editor. We then generate another URL for the end of the route and copy that into the text editor. Next, we need to find the arguments in both URLs that specify location information. In the start point URL, we go through and prefix a lowercase rs for route start to each of these arguments. We also need to capitalize the letter that comes after the rs. We then do the same with the arguments in the endpoint URL, except the prefix is RE for route end. Lastly, we copy the modified arguments from the endpoint URL and add them to the start point URL, making sure to include an ampersand between all arguments. Testing the URL, the Indoors viewer opens with our route and walking directions already generated for the user. We've looked at some simple examples, but when ArcGIS Indoors is integrated with professional work order management or incident tracking systems like CityWorks or ServiceNow, managers and service technicians share a common operational picture of critical incidents for faster response times and more efficient workforce management. When fully integrated, these systems can consume floor-aware indoor maps, expose work order or incident data as feature services, and give technicians a seamless experience moving between ArcGIS Indoors and the other operational systems the technicians use as part of their daily work. Here is an Indoors viewer with a web map that includes ServiceNow incidents. Esri provides a GitHub repository with tools and instructions on how to use open-source platforms, such as Coop, to build your own ArcGIS-compatible feature services to expose work order and incident data. The ServiceNow data exposed in the feature service have been organized into categories in ArcGIS Pro, making it easy for the technician to find incidents and requests in the viewer. The technician can click on an incident to show its location on the map, view information about the incident, and get directions to the incident. The technician can report a new issue by clicking on the issue's location on the map, then using a Launch Action button configured to open and pass information to the ServiceNow web application. The information from the indoor map is passed to ServiceNow and used to pre-populate the incident form. When they click Submit, ServiceNow creates the incident and the feature service automatically updates so that the technician can return to the viewer and after a few moments see the new incident on the map. The technician can continue to move easily between systems as they work to resolve and close their incidents. And this level of integration can also be achieved with the Indoors native mobile apps. Okay, we've covered a lot. So, let's wrap up this session with a brief review. We covered 5 of the feature classes in the Indoors information model: sites, facilities, levels, units, and details. We talked about how they relate to one another using unique values in their ID fields, and we looked at some of their key attributes. In particular, remember that the Levels feature class has a vertical order field that contains the ordinal integer values you'll most likely want to use when coding level-specific functionality in your apps. And the Units and Details feature classes have a use type attribute that's useful for symbolizing rooms, doors, windows, and other architectural details. We introduced the concept of floor-aware maps and got a preview of how they'll be configured in ArcGIS Pro to enable floor filtering of map features. We used our knowledge of the Indoors information model to query indoor map features using the ArcGIS API for JavaScript, and we saw a sneak peek of the new floor filter widget coming soon to that API. And finally, we looked at patterns for integrating the out-of-the-box Indoors viewer web application and native mobile apps with third-party apps using custom launch actions and smart launch URLs. Thank you for watching, and enjoy the rest of the conference.